Hello, cool cats and kittens. We're going to do areas under curves, questions 7, 8 and 9 from the exercise 13E in the Pure Year 1 book. Let's start. So, first question. Bit of a problem solving question. They've even granted it so hard they've given us a box on what we should be doing. So, let's read the question first. Shaded area under the graph. Just to say in this video I'm not going to do too much teaching of the concepts. If we're watching this we should be comfortable with it, and we're just wanting to challenge ourselves to answer the hardest questions in the book. So I'm going to go through the methods but not stop and say why we're doing things in too much detail. We've got given this curve and we want to find the area underneath. So a straight definite integration is going to do this for us. So we want to be integrating between k and 0 the function of the graph, and we're told that it is 8. Really bad wording, but that means equals 8. It took me a few reads of that to figure out what the hell they were on about, but that's what they mean. So we get set up with this, and they've helped us out by setting it up for us over here. I'm going to ignore this equals 8 for a bit. I'm going to bring that back in right at the end once I think I've done enough work to form an equation. I'm just going to integrate this. So integrating my function here. So integrating that, I'm going to get x cubed minus x squared plus 2x plus c, and we're going to do that between the limits of k and 0. So substituting in k, get k cubed minus k squared plus 2k plus c, and I'm going to subtract, well, when I substitute 0 into all that it'll disappear, so I'm just subtracting c. That will cancel with that. So I just get k cubed minus k squared plus 2k, bringing back in my equals 8 now, because I feel like I've done all my integration, I've done all my substitution. I can form this equation now. So let's make it equal to 0. That's how we solve stuff. So quadratics we can factorize, cubics we have a different method. It's called the Factor Theorem, or as I like to call it, chuck random numbers in until it equals 0, because that's literally all you do. I don't know why they call it a theorem. You just say, let's try 1, let's try 2, let's try 9 and see which one works. Generally it'll be a nice low number for you. I'm going to blue Peter. This is one I've done at home. K equals to 2, so 2 cubed minus 2 squared plus 2 times 2 minus 8, well that equals to 8 minus 4 plus 4 minus 8 equals to 0. So we know that k minus 2 is a factor. Reverse the sign, because if we pull a solution from this brackets we'd get k equals 2, which is what we've got there. So from this, I think in this question that's as far as we need to go. We're going to say, well, k equals 2 is a solution. So this value of k here would be 2. I mean, you could go further with this in a certain type of question. So you could go to factorize it, and if you do factorize it, you get this. However, this doesn't have solutions. So it just further proves that we are just looking for one value of k. From this we would just have one value that solves it. Nothing solves this. Okay. Where'd I put my next question? Up high. Finite region of R is bounded by bloody bloop. Find the coordinates of A and B. So Only 2 marks. It should be a nice easy one. So A and B are on the x-axis, so it's where y equals to 0. So 0 equals to minus x squared plus 2x plus 3. I'm going to get everything to the other side to make the x squared positive. And then I'm going to factorise. Minus 3 plus 1 seems to work for me. So then x equals 3, x equals minus 1. So then my coordinates, just have a look at the diagram and see which one makes most sense. A is going to be the one furthest to the left. And there we go. B. Find the area of the region R. So we know what we're going to integrate between. We are going to integrate between minus 1 and 3 because they are our two stopping points and they are our bounds. There we go. So, time to integrate this. So we are going to get minus a third x cubed plus x squared plus 3x plus c between 3 and minus 1. So substitute in our numbers. I'm not going to write out the whole substitution. When we substitute in 3 we should get 9 plus c. And then when we substitute in minus 1 we should get minus 5 over 3 plus c. The plus c's will cancel and we're subtracting a minus, so it's going to be 9 plus 5 over 3, which is 32 over 3, or you can say 10 and 2/3, or you can say 10.6 recurring, which is disgusting, so you'd never say that, or we have a fraction. Okay, here we go. And question 9. I like this little thing where it says use calculus to find it, and then it gives you a hint when it says use calculus, you need to use integration or differentiation compared to what? Getting a ruler out or cutting out some paper and sticking it in and seeing some stuff. There's not really many other methods we have at the moment. You will gain another method in year 2, but it's a worse method than what we've got now. Bit of a spoiler. So, let's have a look. We've got a lot to do here. We need to find, well, we've got our limits between 0 and 2. In fact, we don't have a lot to do. We just need to expand this bracket. So instead of saying this, we don't know how to integrate things like this, but we know how to integrate things like that. So we're going to integrate between 0 and 2 with respect to x. So, integrating this between 2 and 0, and I'm not going to do the whole substituting in. If you substitute this in, you will get 4 over 3 plus c, and here you will just get c. They cancel out, and you get 4 over 3. It's actually quite a nice, easy question.